Hello everyone and welcome back to this project series. In this project, we're building a Reddit thread analyzer using LangGraph. This is the fourth video in the series, and so far we have built a version v1 and v2. So in this video, we'll move ahead and build a version v3. But just as a quick recap, in the version v2 that we built in the previous video, this was basically putting the different elements in a sort of end-to-end workflow using LangGraph, right? In version v1 this was just in a notebook style way, but now we moved to a .py file using LangGraph and one single node that does the job of both the extraction of Reddit data and also analyzing them. Right now, if we look at some of its strengths or like positives from this, now this was an end-to-end pipeline. Basically, if you see, our core functionality is that the user passes in a Reddit thread and the LLM then gives you the insight. This is basically is happening here. We have an end-to-end, so as to say, that's ready. The user passes in the URL and some questions, and from the LLM you get the insights. This is the core, at the core, an end-to-end variant, right? But it's like quick. You also get like a quick thread summary, and it's a simple architecture, right? Just as a good baseline for us to build upon in future, right? Now, what are the drawbacks of this? First, okay, before that, right, like I said, this is like a good baseline. Now we could sort of divide it into two parts, or maybe three. First is, of course, this sort of retrieval aspect, right? Now it has to hit the Reddit data and retrieve all the comments, the replies, the nested replies, title, description, and so on. So this is one area where we can optimize. And second is, of course, generating the insights. So this is one more area where we can optimize. And the third, not a major, is to explore something with the user, with the user's input itself. Right now we are just taking in the URL and the query, but this is also an area where we can think about for any improvements, right? So with that, let's go into some of the drawbacks in this variant. First is that it treats all comments equally, right? What I mean by that is, here we took in like for the example that we showed, right? We had like 120, I don't know, 100 plus comments. What we did was we simply joined all of them together and passed it as the context for our thread, right? Now if you go to Langsmith, we can actually see this right from the very same example that we showed in the previous video. We have all comments, which has all the comments listed here. So there are about 1 or 3 comments, and comment context is simply a combination or like an joined version of all this, right? So we started off this project saying that Reddit has a goldmine of data, but all we did was extracted it and joined it together. So it is still a noise, right? LLMs are good at summarizing and in finding insights, but if you are going to feed it a big block of text, it is not going to do a good job, right? And here we had only 100 comments. What if you're trying to analyze a bigger thread that has even more comments or nested replies? So it is going to do a bad job, right? We want to move from a sort of context variant to like an intelligent knowledge base that it can extract insights from. So it treats all comments equally. That's like one drawback of this. And second is the output is too generic. All we said was, hey, summarize this. We don't want it to simply summarize it. We want to find insights, or find some underrated comments, some arguments, counter arguments, and so on. And all of this can be done only with a stronger prompting, more structured prompt, give it examples of how you want the data to look like, and enforce more structure to it. So to begin with, these are a couple of things that needs immediate improvement to our version v2, and that's what I've done and improved in to build the version v3. If you can see, it has also slightly gotten longer. You might immediately notice that we have one node here and we have two nodes here. I'll come to that. Right, but before that, to start with, the user passes in an URL and a query. And if you haven't already noticed, earlier we passed url.json, like /.json, but we want to try and optimize things moving on from here. All right, we want to put in less burden for the user. It's easier to go to Reddit, copy this and put it in your app than paste and also type .json, .json, sorry. A very teeny tiny update, but hey, all we are doing is passing the URL and the query instead of the .json too. Next is the extract thread data, right? So instead of having one thread that does extraction and analyzing, I've split it into two. One does extract and one does analyze. Now the reason again, when you go to an app like Langsmith to trace the workflow, it is like a standard or like a advised or like good practice, right? To separate to create those separate of concerns, so that you will, in case of any issue, you'll know where the issue is coming from, right? You can point it out and say that, hey, this is the node that is producing inaccurate outputs, so you can go and optimize that particularly. So as a rule of thumb, when you're working with something like LangGraph or such AI workflows, even if a single LLM can do more than one function efficiently within a single node, it's better to separate them, simply because it becomes easy for you to trace the flow of data. One issue with that, it might be that sometimes you're just increasing the token usage simply because you're doing the same work again and again, but that's again a design choice that you have to do. But in this case, we're not doing anything. We're not repeating anything. Both are separate tasks, which was sort of unified in the earlier version, and we have just separated it now, right? So yeah, enough talking. Well, let's go back to this workflow or this diagram. The first node hits the Reddit data and gets us the thread data, but before hitting it, it is appending a dot, like a /.json, right? So instead of the user doing it, this is something that we are automating it, right? So we have got all the data, which is including title, description and comments, right? And now all this data along with the user query is fed into the next node. But if you see here, I've said something like comments filtered, but in the earlier case we had comments. So what we're doing is, this is to sort of address this drawback. Instead of treating all comments equally, what we'll do is, we will try to no prioritize those comments that are useful. Now, how do we do that? If you have used Reddit, you will already know the answer, that these numbers that you see here, basically they are called upvotes, and of course the negative ones are called downvotes, which is basically a good proxy to indicate the to indicate the um, popularity or, like, accuracy of a data, or they simply mean that these data are popular, right, and more people agree with it, right? Because Reddit is sort of like a community driven platform. The more votes a certain reply or comment has, it simply means that those responses are just more accurate or just more popular among the community. So it's more likely to be useful for us, for generating our insights. So what we'll do is we'll also extract upvotes from within this thread data, right? Maybe I think it's nice to add it here. What these We'll extract the title, we'll extract the description, um, and we'll extract the comments plus something called score. So I don't think you get upvotes and downvotes separately, or I think you get upvotes, but also there's this metric called score, which is a combination of upvotes and downvotes, so that's just more accurate. So these are some things that you will get uh, within the retrieved thread data, right? And using this comments and score, we will filter our comments. So maybe we can do like top 50% based on the upvotes. So now all of this is fed into the analyze thread, and you'll see later in the code when we do the prompt that is used for analyzing thread is just a bit more structured and robust now. So the insights are going to be slightly more of course structured, and more meaningful, or easy for the user to make sense of, instead of being something generic that we did here. So ideally we are trying to address these two issues. One is with the comments, and one is with the analyzing the thread. So I hope we now have a sense of what we are doing with version v2 and how this is an improvement to version v1. With that, let's move into VS Code and build this. Of course I've built already, but I'm going to show you how we have done this. All of this are same. Importing library is same, loading the environment variables is same, initializing the LLM is same. Here again this is same. The only thing that has changed is we have an additional state, which is filtered comments, and this is going to be a list of dictionary. So oops, let me pause here for a bit, because there's something that I have to change. Yeah, so all the comments here will feed in not just the comments but also the scores. So it's going to be a list of dictionary, right? And filtered comments is same, but just taking in the top 50. So essentially same as all comments, but only filtered variants. So again this will be a list of dict. And finally you have the comment context. Which is combining all the filtered comments, so that will be a string. And finally you have the inside, which is again a string. Now you have some helper functions here. One is to normalize Reddit data, Reddit URL. So it checks if it has a .json in the end, and if not, then it appends it with .json, and of course a slash. Then you have an helper function to extract comments, but this time with upvotes too. In the previous function, like in the previous version, we had just for extracting comments and the replies, but this time it also extracts the upvotes. It's an easy to read code, pretty much the same structure as v2, so I would encourage you to check this out. And then we move towards defining the prompts. So we have just one prompt here, which is to analyze. And earlier, if you remember, we used a simple one-liner or like a two-liner to mention what the LLM has to do. But here we have brought in a bit more structure. So we say you are analyzing a Reddit thread, discussion thread. Answer the user question using insights from the thread. If there is not enough information, say you do not know. Right? So we wanted to always pick up information only from the context it's provided and not from its generic trained data. right? So that's one. And of course, adapt your response to the complexity of the question and discussion. If the question is straightforward, provide a clear and concise answer, 2 to 4 lines. Do not add unnecessary sections. If the discussion is nuanced, contains multiple viewpoints, or requires deeper analysis, you may structure your response using relevant sections such as these. So I've given brief overview, key insights, important perspectives, actionable takeaways, or conclusion. Only include sections that are genuinely useful for answering the question. Do not force a template, and avoid unnecessary formatting. Be concise, direct, and insight focused. Now, I'm not going to say that this is like the best prompt, but it's surely an upgrade from our previous one, which was generic and vague. But here we are attempting to bring in more structure, right? And the remaining bits are same. And yeah, so here we define two nodes. First is of course the extraction plus this sort of filtering. We this is pretty much the same, extracting. Before that we normalize the URL, and we are sorting it based on the score. We have taken the top 50, so we have divided the length by 2 to find the top 50, and then finally joined all of them. So while updating, we're updating all the comments, which is basically the sorted comments, and then you have the filtered comments, which is the filtered variant after removing the top 50%, and then you have the comment context, which is joining the filtered texts from this. Right, so that was in node 1. Node 2 is a simple LLM call to analyze your thread, but this time we are using this updated prompt. And then you build the graph. All of this is same. Now we have an additional node, so that will come in the sort of sequence. And then it's simple. For testing the workflow, we'll take in the URL, but if you'll notice here, I don't have like a /.json here. We're just going to attempt it with the raw URL, and the user query is same as that we used in the version v2, just to check how the way output would vary. All the initial state are same. We just have one more variable that's there now, right? I also realized that I've just put in a list. Yeah, should be fine, not an issue, I guess. And then we run this variant, right? Let me quickly modify this, call it v3, and run this. Of course, we'll go to LangSmith to see how the flow is happening this time. Now, as a within a quick look, you can see how the answer is a bit more structured now, with sort of the subsections that I have mentioned. It has also given me an actionable takeaway. We'll see more of this in LangSmith. Let's wait for it to refresh. And I hope this is the one. Yeah, one thing that you'll notice immediately is, although the time has pretty much remained the same, the latency, the token usage has reduced by almost half. And you also see the underlying cost has also reduced drastically. Now, why is this? It's quite obvious for us now, that earlier we fed in the entire comments, but now we are prioritizing only the top 50 comments, right? Or like top 50% comments that's useful for us, right? So the eventual context that's flowing into the LLM is less, and hence the reduced token usage, which is a win for us. Because this was in fact a smaller thread, right? When you want to scale this, all of the smaller optimization will eventually add up and help you save tons of money, right? Now with that, let's go inside this trace and see how things have changed. Of course, you have two nodes here, extract thread node and analyze thread. If you'll see, you will have LLM call for just for one, because that's how it is. This is more of a Python function that's put into this node, but this is the one that actually has an LLM call. In this node, the input is the URL and the user query, and the output is, if you see, let me close all of this. So first thing you'll see is you'll have all the comments. You'll see the comments and the score, which is also sort of sorted in decreasing order. So you have them neatly sorted out, right? Now what we'll do with filter comments is basically take the top 50% of them. So that's done here, and in the comment context you will basically join all the top 50 comments, to because these are the most popular ones, so these are more likely to have useful information, right? Apart from this, of course, you have the title and description. Now in the next node, we have all this input that's fed in: comment, context, description, and title, along with the others, and the output is basically your insight, right? Maybe let's take a quick look at this insight. uh, yeah, of course, this is a bit more structured for you to learn and like grasp immediately from a user point of view. So yeah, that's pretty much the version v3. I hope this was useful, and I hope we build that sort of intuition as to identify the drawbacks of a certain variant, to structure, to identify areas for optimization. Like we saw how this could be one sort of area, the retrieval is one area and the actual generation is the other. So that way you can create those mental blocks for you to think about optimizing a certain for functionality, a certain section of your app, right? And we identified how certain things are obviously wrong in this and that needs improvement, which then was built in version v3. Of course, apart from these two, we also sort of split the node into two to separate the concerns and did a tiny update to our URL. So I think 4 changes in total for this v3. Yeah, that's pretty much it for this video. We'll follow a similar cycle of identifying the positives from v3, the negatives from v3, which will then help us building the version v4. Like I always say, I'm quite active on LinkedIn. Do reach out to me if you have any questions, or do leave a comment below, and I'll respond to you. The all the code is available on GitHub, and the link to which is in the description below. With that, thanks. I hope this was useful, and until then, take care and thank you.